Hey everyone, welcome back to the Codeverse channel. I hope you guys are doing extremely well. So today's lecture is the first lecture on the series on prime numbers. But before starting with the first lecture, let me introduce you myself. My name is Raj Vikramaditya. I'm generally known as a striver in the programming community. I'm a competitive programmer. Currently, I'm working as a software development engineer at Media.net. Prior to this, I was working at Amazon. I'm rated candidate master at Codeforces. I'm a 6-star at CodeChef. I have a couple of years of teaching experience, and I have also around 90,000 subscribers where I teach. So the subjects that I'm going to take in Unacademy going forward are competitive programming, data structure algorithms, C++, and everything that's related to interview preparation. So without wasting time, let me introduce you the lecture series on the prime numbers. So today is going to be the first lecture. So just giving you a small brief about what we will be learning today. We'll be learning about some facts about prime numbers. We'll also be knowing about the code, how to check primes. At first we'll be starting with the linear solution, then we'll be optimizing that, and we can see how much can we optimize check of prime, and after that I'll be solving probably some practice problems. So I'll be giving you some problems so that you can think by the concept of prime that I will give you. Okay, so that will be the first lecture. So at the end of this video you'll be taking away these things, and the lecture 2 will be about sieve. Yes, that's a very important algorithm. This algorithm is generally used in competitive programming as well as in interviews. The lecture 3 will be practice problems on sieve. In lecture 2 I'll be teaching you the entire sieve. That's going to take some time. After that we're going to do couple of practice problems on lecture 3. Once lecture 3 is done, we'll be moving to lecture 4, and in the lecture 4 I'm going to teach you how to prime factorize a number. Not only that, I'll also be teaching you how to answer queries on prime factorizations in very efficient time. And right after that I'll also be doing some practice problems on prime factorization. Once we are done with lecture 4, we will move to lecture 5, where we'll learn about segmented sieve. Yes, that is one of the most important algorithms on prime numbers. So I can assure you, once you have seen all these 5 lectures, yes, once you have seen all these 5 lectures, I think everything about prime numbers will be covered. And if there is a question in competitive programming, in interviews, in coding rounds, you'll be able to solve it. You will be able to solve it, but the condition is you have to watch all the 5 lectures. And are these 5 lectures free? Yes, they will be absolutely free, and you'll get all these 5 lectures on this Codeverse channel. So if you haven't subscribed it, make sure you subscribe it. What will be the timing of the lectures? I will rather prefer you to turn on the bell icon so that whenever the lectures are posted, you can directly come across and watch it. So if you want to get an access to all these batches, yes, I'll come under the competitive programming subscription. You can check out all the competitive programming section, that is programming subscription section, that is on the screen. What you'll get is India's best programmers. Yes, you saw my credentials. You'll get similar or even much better credential peoples on Unacademy Plus. Even you'll get a lot of interactive live classes. Nothing is recorded. Yes, you will get direct live lectures where you can interact with the instructor. Now there will be something like a doubt support, so that after the classes, if you have any doubts, you can just raise it and that will get solved. And obviously you will practice problems at CodeChef if it is a obviously competitive programming or data structure algorithms course. And in order, if you want to get the subscription at competitive programming, make sure to use the coupon code STRIVER. Yes, if you're going to use that, you're going to get 10% flat discount. So just remember this coupon code and make sure you use it if you're willing to take a subscription. So if you're new to our channel, please make sure you like, share and subscribe. So that's the first thing that you should do before starting off with the lecture. So without wasting any time, let's start with the first thing, some facts about prime numbers. Now everyone knows what are prime numbers. Let me just talk about some facts about prime numbers. Now do you know that 2 is the only even prime number? You'll be like, yes, we know that. Okay, fine. So just consider that one of the facts, that 2 is the only even prime number that exists. Now the second fact I'm very much sure that you don't know. Every prime can be written as 6b plus 1. B can be any natural number, or 6n minus 1, except 2 and 3. Okay, now what is the 6b? Again, b can be any natural number or n can be any natural number. Now when I say that 6b plus n or minus 1, for example, let's take something as 11. You know 11 is a prime number, correct? So how will I do that? If I say 6 into 2, that's 12, minus 1, that's 11. So 6 into 2. So that is why you can write it as 6n minus 1 or 6n plus 1. So every prime number can be written as 6n plus 1 or else 6n minus 1. Remember this, except 2 and 3. Next, the Goldbach conjecture. What does that mean? Every even integer greater than 2 can be expressed as sum of two primes. Okay, so what does that mean? You take any even integer. For example, let's take 16. Come on, think of two primes expressing 16. Can I say 13 plus 3? Yes. So any even number can be represented as a sum of two primes. Okay. Next, Wilson's theorem. I'll come to this afterwards. I have to use the blackboard in order to explain that. Let's come to the last fact. That is 2 and 3 are the only consecutive numbers that are prime. I think you don't know that, but right now you can observe that. Yes, 2 and 3 are only the consecutive primes that are available. So now let's get started with the Wilson's theorem. So what does the Wilson theorem state? The Wilson theorem states p minus 1, and if you do a factorial, you will get p minus 1 if you do a modulo of p. Now what does this mean? This is what the Wilson's theorem is, or what is the significance of this? Let's understand the significance of this at first. So assume I give you a number like p equal to 5. Okay, given that p is prime, so Wilson theorem states 5 minus 1, that's 4 factorial. Okay, equal to should be 5 minus 1, that's 4, modulo 5, so that's equal to 4. So it is saying 4 factorial. Again, a modulo p is there, so modulo 5 should be 4. Let's see, what is 4 factorial? That's 24. 24 modulo 5 should be 4 is what they are saying. And if you observe, 24 modulo 5 is 4 itself. So that is what the Wilson theorem states. If there is any given number p, if you do a p minus 1 factorial, that will result in p minus 1 if you do a modulo p. Yes, if you do a modulo p, it will result in p minus 1. So that is Wilson's theorem. Now just facts, you just need to know about it. It's not used in competitive programming. The stuff that is used in competitive programming is check of primes, queries on primes, and stuffs like that. We'll come to that in the upcoming lectures, but as of now, let's understand how to check off prime. So let's quickly erase this without wasting any time. So if I ask you what is a prime number, what will be your answer? You'll be like, a prime number is basically a number which is divisible by 1 and itself. Am I correct? You'll be like, yes, but we can better the definition. Can I say a prime number is a number is a prime number if it is divisible by 1 and itself, and the factors are 2, and the number of factors in total is 2. You'll be like, why? 1 in itself, yeah, if a number is 1, I can also say 1, it's divisible by 1 and itself is 1. So that is why, in order to better the definition, I can say it's divisible by 1 and itself, and the number of factors significantly should be 2. You'll be like, yes, that is correct. That is absolutely correct. So if I ask you, how do you check if a number is divisible by someone or not? You will be like, that's very easy, Raj. That will be like 12 modulo I. If this is 0, like if the number is 12 and I write 12 modulo I equal to 0, I can say that 12 is divisible by I. Correct? So can I say, obviously I cannot check for if the number is divisible by 1 and itself, because the key idea is only. It is divisible by 1 and itself only. So what I need to check is, can I check if the number of factors are 2? I'll be like, yes, I can. Like, yes, I can check if the number of factors are 2. So why don't we do that? We basically check if the number of factors are 2 or not. So if there is a number n, for example, let's assume if there is a number n, how do you check if that number is a prime or not? You loop from 1 till n, correct? And you check, does 1 divided, does 2 divided, does 3 divided, does 4 divided, does 5 divided, and so on till n. You do that, correct? So why don't you do that over here? So can I say, I'll loop from 1 and I can go on till n. Again, in C++, Java, doesn't matter, the code's gonna look very much similar. So I'll be like, if n modulo I is equivalent to 0, that means it divides. Yes, it means it divides. So can I possibly keep a counter? I can definitely keep a counter. And can I say I'll just do a counter plus plus over here, and I'll end the for loop. I'll end the for loop over here. And what I will do is, okay, obviously definitely lesser than equal to n. I'll end the for loop over here. Right after this for loop is executed, can I say if the count is equivalent to 2, I can probably print, you can write cout in C++, and in Java you can write system.out.println. That is dependent on you. I'm basically focusing on writing the pseudocode. So can I say this is how the code will look? You'll be like, yes, this is easy. I know this is easy. We'll come to the optimized version. But in order to understand the optimized version, you should definitely understand this. So can I say that if the number, for an example, is 11, so at first I will be 1, goes inside 11 modulo 1. Yes. So the value of count will become 1. Next, I becomes 2. 11 modulo 2. No. Next, 3. 11 modulo 3. No. Next, 4. 11 modulo 4. No. Goes on like 5, 6, 7, 8 till 11. And the moment it gets to 11, 11 modulo 11. Yes. So the count will become 2. And at the end, the for loop will execute because it will become 12. And this condition will ultimately be false. So once the for loop is executed, can I say if the count is equal to 2, okay, that means it has exactly 2 factors. And if it has, can I say that's nothing but a prime number, correct? And if it has more than 2 factors, for an example, if you take a number like 6, can I say when I will be, let's change the color, when I will be 1, when it will divide, when I will be 2, it will divide, when I will be 3, it will divide, and when I will be 6, it will divide. The loop will run from 1 to 6, but there will be 4 factors. So hence I cannot call this prime, whereas I can definitely call this as a prime number. So if we talk about the time that it takes, what will be the time complexity? Now, for people who do not know what is time complexity, is generally in computer programming or in data structure algorithms, I'll not go into BIGO wala stuff, like the asymptotic wala stuff I'll not go. I'll much more keep it to the BIGO wala stuff that we use in computer programming. We basically say the number of iterations. Can I say the number of iteration the for loop takes is n, because first I will be 1, then 2, then 3, then 4, then 5 until n. So hence the time complexity becomes BIGO of n. Okay, that's a good one. That's a good complexity. But can we optimize it further? We'll be like, yes, we can. Definitely we can. So can you think of a better optimization? If you can, probably you can tell me in the chat section. So I can think of a better optimization. Can I say I'll try to, like, I know this can be done as n by 2, but again that's almost near about n, so I'll not be discussing that. Let's keep it aside, and I want to optimize it much further. I want to make it something better than n, not near about n. I want to optimize it much further. So I'll just tell you a property which you have to observe. Yes, this property you have to observe, otherwise that wouldn't be possible. So let's take for example a number like 36. Okay, let's take a number like 36, and let's write down the factors. The first factor that I write down is 1 into 36, right? If I write the first factor 1, the other factor will be 36. Perfect. If I write down the next factor, that will be 2 into 18. The first factor is 2, while the next factor is 18. Perfect. Can I say 3 into 12? The first factor is 3, whereas the next factor is definitely 12. Let's go back. Let's go front, sorry. 4, while the next factor is 9. Okay. Next, 6 into 6. Next factor is 9 into 4. Next is nothing but 12 into 3. Next is nothing but 18 crossed 2, while the next is nothing but 36 crossed 1. I'm like, okay, perfect, that's perfect. So can I say if I carefully look this portion, this portion is a revert of the initial portion. If you carefully observe, it's a revert of the initial portion. What do I mean by revert? So let's quickly just draw this off. if I just draw this line rather, can I say this 1 crossed 36 is 36 crossed 1? It'll be like yes. Can I say if this 2 crossed 18, this is 18 crossed 2? It'll be like yes. Can I say if this is 3 crossed 12, this is 12 cross 3? Yes. If this is 4 crossed 9, this is 9 crossed 4. And yeah, this is a similar kind of thing. 6 into 6. That is why we did not get a revert of that. But we can see revert. So can I say, if you technically observe, if you just observe it logic wise, can I say for 36, for something like 36, if I loop till this 6, if I loop till 6, I can actually get all the factors. Can I or can I not? Yes, I can. Yes, I can. How will I get that? Just imagine this is your I. Okay. Just imagine this is your I. I is like 1, 2, 3, 4, 6. So can I say, what will be this guy? If this is I, can I say this will be n by I? You need to carefully observe. Will this be n by I? It will be. If your I is 1, the other factor will be 36 by 1. If I is 2, the other factor will be 36 by 2. If I is 3, the other factor will be 36 by 3. If I is 4, the other factor will be 36 by 4. 9, if it is 6, the other factor will be 6. So I can observe. Now, can I trim down our question and can I say this, that for a number to be factor, if I can simply count down the factors, I think my job will be done. Like, how will I count down the factors? Okay, so I'll write the code and in that way I'll explain you. So can I say till 6 I will run? So that's nothing but square root, because square root into square root is the last smallest factor. Like last factor, if you consider this increasing order, because beyond square root the reversal will start. Beyond square root, you see the reversal starts. So till square root is what you can have factors, correct? So what you will do is, you will start from I equal to 1, and you know, over here also I'll teach you something, but as of now not. So if I write the code, can I write it like this? Yes, I can. And can I say, if I is the factor, can I say if I is the factor, then probably I can keep a counter variable which counts me the number of factors. And I'll do counter plus plus. Now my question to all of you is, shall I do a counter plus plus or a counter plus 2? Shall I? Because for 1 there is another factor 36. For 2 there is another factor 18. For 3 there is another factor this. For 4 there is another factor. But for 6 there is not another factor. This is what you should observe. So it's very, very important that you check if n by I, which is the other factor, is that not equivalent to I? Because in this case, as you saw, they both are equivalent, guys. So you should definitely check if they're equivalent or not. And if they're not equivalent, then only you will do a counter plus plus, and after that this if will change. Once you have written this entire piece of code, yes, once you have written this entire piece of code, you can say that if counter's value is equivalent to 2, then I can say that it's a prime number, or else you can simply say that this guy is not a prime number, correct? So how much is the iteration that you have reduced? Previously it was big of n iterations. Now can I say the iterations that you have reduced is big of square root of n? Is it? Yeah, the for loop runs for square root of n, but is the complexity square root of n? Is the complexity square root of n? How many of you think that? How many of you think that? You can tell me in the chat section. I'll be reading the chats while I premiere the video, but yeah, you can tell me in the chat section. So I'm very much sure that every one of you think it's as big of square root of n. What if I tell you that this is not the complexity of this for loop? Rather, the complexity is square root of n into logarithmic of n. You'll be like, why is that? I'll tell you. Every time you initialize, the initialization is done for the first time in the for loop. Then the check happens, then it goes inside, then while it comes back, it increases the value, then again the check is done. So every time you check, you're actually executing the square root of n. Some servers might cache this value. Yes, some servers might cache this value, but a lot of servers will not cache this value. So what it will happen is the square root is every time executed. And if you know C++, STL or a Java collection, the math.square root or the square root function tends to take logarithmic time. So in every iteration, the comparison is done and you end up taking a logarithmic time. So that is why instead of writing this, people generally tend to write this I into I lesser than equal to n. This is similar to this guy, but this won't take any time, whereas this takes log n. That is why I said this guy has a square root n, but if you omit this and you write this, the complexity will become square root of n. And that's the most, or like there are other methods, but those are like not genuine methods, like they have some error rate. Like there are other methods, but they will have error rates. This is the method, this is the most optimal method only for checking primes. I'm not talking about queries. If a number is given, single number, you want to check prime, this is the most optimal and the most accurate method. I'm not talking about the accuracy. Like there are methods which is like hidden trial kind of thing, where you're not always sure that the answer will be correct. So that is why I will not be explaining that, because in competitive programming, it's all about getting the answers correct always. So what is the complexity that we got? We got something as big O of square root of n complexity, correct? That is in order to check if a number is prime or not, correct? So we are done with this. Now, what kind of questions can come from here? What did you understand? You understood something like factors. What if I give you, probably I give you that count me or print me the sum of the divisors or the sum of factors. Can you do that now? Can you people do me this question? Print the sum of factors. You'll be like, yes, we can do that. How will you do that? You will simply write I equal to 1. But this time, instead of writing that, you will start writing something like this. I into I lesser than n and I plus plus, correct? And right after that, you'll say n modulo I is equal to 0. That's a factor. So to count the, you can keep a sum variable as 0. And what you can say is sum plus equal to I, correct? You can say sum plus equal to I. And again, I'm writing the pseudo code. I'm not going into C++ or Java, so that everyone can follow this entire lecture series. Okay, so don't do in the comment section C++, Java, we need Python. It's a pseudo code. Everyone can write the code. Cool. So what I can say is if n by I is not equivalent to I, this is the very important condition. People tend to miss this. This is a very important condition. People tend to miss this because checking of equality of factors is very important. It might happen we have a factor, the other factor is the similar one, so you don't need to count it twice. That do both are same factors, there's no need to count twice. Okay, so I can say sum, the other factor is n by I, so I'll write sum plus equal to n by I. This is how the sum variable will keep the sum of factors. Count of factors, you can definitely do it. Now, when to use this logic, how to understand that a question is on this. Generally, you will not find questions which are directly related to primes, because a lot of times, people will give you questions where they will be like saying ki constraints are n less than 10 to the power 6, but they will give you test cases. We will be discussing that case in the next lecture, but as of now, this is what you can definitely do it. So I'll come to the next question. So the next question is from CodeBeyond, and I'll be leaving the link in the description, and I'll be explaining the question. I don't want you to read the question and waste time in this. Let's quickly get into the question. So the question stated, you'll be given an n. Okay, that's the question. The question stated, you'll be given an n. Okay, and you need to figure out three integers, a, b, c. These are the three integers that you need to figure out. Cool. Now you know that the number is n and you have to figure out three integers. But what are these three integers? You have to figure out three integers in such a way that a crossed b crossed c is equivalent to n. That's the condition. Okay, but there are some other conditions. A should not be equal to b, should be not equal to c, and no one should be equal to 1. Okay, that's the condition. None of them should be equal, basically saying that all three of a, b as well as c, all three should be distinct as well as they should not be equal to 1. Okay, so I need to figure out 3 numbers, and the constraints of the question stated that n is lesser than 10 to the power 9. That is what the constraint states. N is lesser than 10 to the power 9. So generally when you see such kind of constraints and you see values as n is 10 to the power 9, you get an intuition that this is something which uses square root complexity, because n is 10 to the power 9. And let me tell you, the time limit for 1 second, whenever you see in programming platforms, Codeforces, be it CodeChef, if you see a time limit of 1 second, which that generally signifies you can run at max of 10 to the power 8 operations. At max 10 to the power 8 operations. So something like 10 to the power 9, how much time will it take? It will take up around 10 seconds. Yes. Don't think it 10 to the power 8, 10 to the power 9. Only power 1 increase. So time will increase by 1. No. That is basically into 10. These operations into 10 is 10 to the power 9 operations. So this time is 1. So 1 into 10 is 10 seconds. That's unitary method. Don't do it 10 to the power 8, 10 to the power 9, multiply 10. No. Don't do it. People tend to do it. Okay. So 10 seconds, and if the time limit is 1 second, it's going to give us what? Theory. So that's why you cannot implement a big of n solution over here. This is where you can think of a better complexity than big O of n. So as I know, the better complexities are like square root of n or something lesser than square root of n, be it logarithmic of n or something like that. Obviously, I'll not go into logarithmic. Because since it says key 3 numbers are multiplication, it gives me an idea that these are kind of factors. Gives me an idea, and these are kind of factors. So I'll try to solve it in terms of factors. Okay, I'll try to solve it in terms of factors. Cool. So let's quickly erase this, and since we have figured out that we need to solve it in terms of factor, we will try to solve it in terms of factors, because the constraint was n 10 to the power 9. That is why we got an idea that okay, we should think in terms of factors, because we have a square root method in factor. Cool. So how will I think a into b into c equal to n? So can I say, just think greedily, can I say, if I have a, okay, if I can find a, then let's club b and c together. So if I want a and I want them to be not equal, like all these guys to be distinct, a, b, c to be different, the greedy nature of me will tell me ki a ko take the smallest, take a as the smallest factor, then whichever is the next smallest take b, and whichever is left will become c. Logically, that is the answer. Like logically, that is what you should think when you're approaching such problems. You'll be like, find out a, find out b, and once you have found that out, definitely c will be n, c will be this. If you have found out a and b, and in order to make sure ki a is not equal to b and is not equal to c, let's take a as the smallest, then the next smallest will be b, and the remaining guy, if there is distinct, will definitely be greater than that if there is, because I've already made 2 guys smaller. The other guy will be greater if there is a greater guy, it will automatically be greater, correct? So if you did not understand, no issues. I'll be taking an example in order to explain this case in a clarity. Okay, so let's take n equal to 64. So if I take n equal to 64, what's the smallest factor? Think in your brain, what's the smallest factor of 64, guys? That's 2. Easier. 1 is not a factor, man. Like smallest factor other than, sorry, 1 is a factor, but smallest factor other than 1, it's not equal to 1. What's the smallest factor of 64? You'll be like, it's 2. Perfect, it's 2. So I've written 2. Now can I say, once you've figured out a, what's b into c? That's n by a. Can I say b into c is n by a? Or I can say 64 by a, that's 32. So can I say I'm left off with b into c? That's 32. So again, apply the same logic. Find the smallest factor of 32, but make sure that smallest is not 2 and not 1. Like, okay, the smallest factor of 32 is 2, but I don't need that. Let's take the next smallest. That's 4. So I'll take that. Okay. So I've taken the next smallest factor of 32. I've got it as 4. Perfect. What's the next number? Can I say, if I've got A, if I've got B, what will be C? C will be 64 by 2 crossed 4. That's 8. Do you actually need to find C? Obviously not. You don't need to scroll for smallest factor because the remaining element will automatically become C. So since you took the smallest guy, it automatically made, like, you took two smallest guy, it automatically made sure that the third guy will either be equal, like that will automatically be greater if there exist. So I'll give you a counter example. So let's take this. If I give you n equal to 8 and let's apply the same method. So if I apply the same method, the smallest factor that I'll get is 2 of 8. Right after that, b crossed c will become 8 by 2, that's 4. Now what's the smallest factor of 2? Smallest factor of 4 other than 2? I'll be like, it's not 2 definitely, it's 4. So you'll write off the smallest factor other than, yes I repeat, other than 2 in 4 is 4. So what will be C left off with? C will be left off with, the number is 8 and A is 2, B is 4. So it'll be 8 by 8, that's 1. So what happened was, since you made sure these numbers were taken smaller, this guy, if there existed, it would have been greater, but since it did not exist, it will come down to something as 1, and you know 1 is not possible. So for this, the answer is not possible. For this, the answer is possible, and the question stated you have to print the 3 integers. The question stated you have to print the 3 integers. So you can definitely print the 3 integers. I hope you have understood. So let's quickly write down the code for this. So I'll be using the Sublime text in order to write down the code. So what does the question state? You'll be given an n. So let's take the n. So can I say I'll be requiring A. So initially let's keep it as 1, B as 1 and C as 1. I always require these 3 guys, correct? So can I say I'll be requiring the smallest factor of n as of now? Okay, so I'll be starting from 2. That's for sure. I'll be starting from 2. How do you get factors? I explained you how to get factors. That's a square root technique, man. So you move like a square root technique. That's how you get the factor. Can I say the factor is I? I'll be like, yes, it's I, but I need the smallest. So since I'm starting from 2, can I surely say this will be my smallest factor? Because A, I'm finding A. So I'll be like, this is my smallest factor, break. So I've got my smallest factor. So if I've got n, if I've got A, what will be n now? Can I say n will be n by A? N will be n by A? Correct. Yeah, absolutely correct. So what I'll do is, now let's try to find this guy B. Let's try to find. So can I say if I starts from 2 and goes on like again n, and this is I plus plus. Cool, perfect. So I can start with 2. I into I lesser than equal to n and I plus plus, correct? So what do I need? I need a factor, smallest factor, which is not A and not 1. So I'll be like, okay, if n modulo I is equal to 0, I is a factor. And what's the other factor? N by I not equal to I, that's the other factor. Just a small thing, why did we not consider the other factor over here? Who can answer this? I think everyone can. Because if we get I, that's definitely going to be the smallest factor. And over here, why did we consider n by I? Because I can be a factor here, but that might be equivalent to A. Right? In that case, you have to consider, na? That might be equivalent to A, na? In the first case, this I would not be equal to A. That's for sure, because A has, like, there's no one to compare. But over here, you have to compare that with I, because you have already taken someone. You have already taken A. So you need to compare with that A, correct? So B will be minimal of B, comma, what? Obviously, I. So you can have your B ready. What will be over here? Can I say I'm having n by I as the factor? I just need to check if n by I is not equal to A. If it is not, can I say B will be minimum of B comma, obviously n by I. So can I say this for loop will make sure I get the smallest factor of n as of now when divided by a, and that's not equivalent to a, I'll be like, yes, we will. So after this for loop, we have b. Can I say c will be n by c, because n was already n by b, because n was already divided by a. Now I'll divide n by b. So can I say I have an c as of now? What's the last condition I need to check? The condition that was given to us without actually brainstorming, we can just simply write this, right? And the last is she should not be equal to 1. That's it. Simple as that. It becomes as simple as you can just get it. That is if all of them are, you can print it. Probably you can print that yes, there exists a number, and you can definitely print the combination as a and b, or else you can say that there doesn't exist a number. I'll be leaving the question link in the description, by the way. The question is product of 3 numbers from Codeforces. The question goes by the name product of 3 numbers at Codeforces. I'll be leaving the link in the description for sure. So that is how you can solve. And this was a Codeforces C level problem. Yes, it was a Codeforces C level problem. So you were able to solve a Codeforces C level problem just by knowing the concept of factors. So what's the complexity that we used? We figured out factors twice. So I can just sum it up to square root of n, like I can just concentrate it to square root of n. And again, the constraints stated n was lesser than 10 to the power 9. So can I say if n was 10 to the power 9, square root of n is an optimal solution, because square root of 10 to the power 9 is somewhere big O of 10 to the power 4, like something greater than 4, and something lesser than 10 to the power 5. 4 point something, like something greater than for sure. So greater than 10 to the power 4, and as I said, 10 to the power 8 is 1 second. So this is well inside our time limit. So guys, this will be it for the prime first lecture. I hope you have enjoyed it thoroughly. Just in case you did, please make sure you like this video, because that is what will keep motivating me to bring such free amazing classes. And yes, if you're new to our channel, please make sure you consider subscribing it and pressing the bell icon, because the lecture 2 will be coming very soon, and that will be much more interesting than this. So with this, let's wrap up this video and meet in the next one. Bye bye, take care.